Hello, future listeners. Here is another video given as quiz 4 in statics under the topic rigid body equilibrium in 2D. So here's the problem in the first section, 7:40 a.m. to 9:10 class. This is problem 2 of their problem. Consider the frame shown and a system of frictionless and very small pulleys where a suspended weight W is attached. Determine the support reaction at the pinned base E, this is the pin, in terms of W if the frame has negligible weight and is held in equilibrium. So take note, the frame has negligible weight, only the weight here and the reaction tensions here will be considered as well as the support reaction at E. Take note also that this frame has a thickness of 0.5 meter, 0.1 meter rather. So 0.1 meter, and we have A, pulley B, C, so which can be considered a point based on this information or given. So for the free body diagram, this is the free body diagram. We have the weight W. The weight here supposedly is, the tension here is W and counteracted by the tension here, which is also W. So that's why I'm not showing it, because for this portion of the cord, the tension which is equal to W will just cancel, or this cord is in equilibrium. So we will be consider this W here. Now, we will call the tension in this cable or cord as T, and because this is 1.25 and that is 0.05, half of the thickness of the frame, so therefore this is 1.2 from H to this left bottom corner, 1.2 meter, and because this is 1.6, the slope of this cord therefore is 1.2 divided by 0.4, which is the common factor, so it reduces to 3. 1.6 divided by 0.4 is 4, so we have 3, 4, 5. Likewise, for this cord here, the horizontal distance from A to center E is 0.95. 0.95 minus 0.05 again is 0.9. So 0.9, 1.2, the common is 0.3 meter. So 0.9 is 0.9 up to here, bottom right corner, is divided, 0.9 divided by 0.3 is 3. 1.2 divided by 0.3 is 4, so we have 3, 4, 5 also. We then resolve T into its components, namely T times 3 over 5 for this horizontal component of T. For the vertical component of T, it is T times 4 over 5. It's now represented here, so we remove this. Then for W, we have this horizontal component is W times 3 over 5, so that's 3/5 of W. The vertical component is W times 4 over 5. So this is now the complete free body diagram with components of reactions assume positive EX and EY. Now the tension, this is attached to the ground, this cord here, then the ground will react. So the ground has nothing to do with the frame. So only these components of weights, that weight, and the components of tension. Then we want to solve for T. So we want to express this in terms of W. So we sum up moments about E equals 0, considering counterclockwise as positive. Beginning with the horizontal component, 3/5 T, the moment arm is 1.6, 3/5 T, 1.6, counterclockwise. The vertical component is also counterclockwise, so plus 4/5 T times moment arm 0.05. So half of 0.1 is 0.05. Then equals clockwise moments. All these are clockwise about E. So beginning with W, the moment arm is 1 plus 3/5 W, the moment arm is 1.2, then plus 4/5 of W, the moment arm is 0.05. So using your calculator, combining these values, this is just 1T or simply T, and the right side is W plus 3/5 of W times 1.2 plus 4/5 of W times 0.05 is 1.76 of W. So that means T is 1.76 of W. So having found T in terms of W, we can now set up summation forces X equals 0. So we have EX plus 3/5 W equals 3/5 T, and T is 1.76 W. So solving for EX, it is 0.456 of W. Likewise, summation forces Y equals 0. So we have EY equals 4/5 of W. We have 4 minus 4/5 of W, this one, minus W, and minus 4/5 of T, and T is 1.76 W equals 0. So solving for EY is 3.208 W. So the magnitude of the reaction therefore is square root of EX squared, quantity 0.456 W squared plus quantity 3.208 W quantity squared. So the magnitude of the reaction at E in terms of W is 3.240 W, and the angle of inclination of that reaction is inverse tangent of 3.208 of W divided by 0.456 of W. So using your calculator, so E is directed up to the right with an angle of 81.91 degrees with the horizontal. So that's it for this video.